If you don't know who I am, my name is Chris Kelly. If you thought this was Brian's talk, I think that's next door. So I would recommend that one at some point in time. It's probably a great talk. Brian does a great job, but hopefully you're here to see me. Thank you for coming and giving me some time today. I really appreciate that. On the interwebs, I go by Amateur Human, and so you can hit me on Twitter and GitHub and all the internets of various sorts at Amateur Human. I'm open for anything. I love chatting and talking, so that's usually, Twitter's a great way to kind of get in touch with me, and if you want to have a longer conversation, then email after that. I work for a little company called New Relic. You might have heard that we're hiring, obviously, and I would like to promote that, and I really enjoy working at the company. I'm a happiness engineer there, and what that really means is I get to work on stuff that makes people's days better. And now I'm currently building out a labs group that really kind of gets to look at stuff that's interesting in the world but doesn't have a direct relation to our current products, and see how those might apply maybe in a couple years. But it's a lot about experimentation and fun. So I'm currently building that group out and having some fun times with it. And we also have a party tomorrow night. So if you guys haven't signed up for that, you should, and come and hang out with us and learn a little bit about us. So this is really a conversation. These ideas that you're going to hear aren't solid. I haven't said these are how I do things or how I always do things. This is an evolution of some ideas. You're going to hear some things that are kind of emerging. There's going to be some buzzword bingo we'll play a little later. And so keep that in mind that we're actually having a conversation here, and I want to continue this conversation. I want to hear about it later on Twitter and want to know what your thoughts are, how other people are doing it, because it's very, very new. So most recently, so I'm from San Francisco, and I gave this talk for the very first time a week ago in Poland, so at Railsbury. That was a very exciting conference. Its tagline was for curious developers. So this talk happened to fit really well into that. And so I flew halfway around the world to go to that, and as apparently is tradition, Railsbury and Conf like to butt themselves up against each other after a week, so then I have to fly across the world again. And luckily for me, I actually am speaking on Ruby Garbage Collection in Scotland, so I have to fly across the world again in a week after that. And then I'm going to spend a little time in Poland again, which will be my second visit in Poland, to go to DjangoCon EU, and don't hate me, I'm just going because I'm halfway across the world. So I'm going to then fly all the way across the world again. And so that's about the next 5 weeks of my life. Oh, and I stop at Denver a little after that. So I wanted to get to know kind of what I do and where I go, because a conversation is about building friendships, it's about understanding context. And so I'm bouncing around the world and kind of meeting all these people and getting these ideas. And that's really where a lot of this talk comes from, is having interacted with a lot of different people and kind of experimenting with that. The first web browser I ever used was Lynx. I'm not sure how many of you are familiar with Lynx. Nice, I love it. So it was probably as usable as this slide is right now. So it's a text-based browser. It didn't have images. I was using the internet before the image tag was even ratified yet in HTTP. So that's good times. And I wasn't really excited about BASIC or computer programming or anything like that. That wasn't what got me excited. What got me excited was the internet. I really came into my own when it came to being able to browse online and explore what the world has to offer when it comes to the internet. That's really where I spend a lot of my efforts and a lot of my thinking. So I'm very much internet-focused more than I am just software developer-focused. This is GIF. It's an excellent peanut butter. That's animated GIF. That is not an animated GIF. I say GIF, other people say GIF. We're friends now. We're having this conversation. We're becoming friends. We can disagree on that, but it's animated GIF in my world, not animated GIF. I also love Ruby, and this is important. I call myself a Rubyist, not a software developer, because the tools we use play a lot of context in what we think, right? If I'm a Rubyist, that means I think about TDD, or I think about the interface of the programming language. If I do Python or Java, I think about those things differently. So it's important for you to know that I'm a Rubyist and not just a software developer. I care about the language, and I care about the things that it kind of bestows upon me. Thank you. So you're here because you have a monorail. You probably have an application that's a few years old. It's been Growing and maturing. You probably weren't thinking about OO design 3 or 4 years ago when you started the thing. That conversation has really emerged in the last 18 months or so, and that's been very exciting for us as a community. You might have actually built your monorail pretty well. It might have some stuff living in the lib directory, so you kind of got it isolated and it's easy to test. And you're like, this thing's giant, and I can't deploy it. I can't deploy components of it very easily. I have to do all of this extra labor in order to get it to scale. I can't change it very easily. And so you're like, how do I get rid of this? How do I fix this problem? And that's probably why you're all standing here in the back of the room. This isn't really a talk about SOA, service-oriented architectures. This is a talk about that world, but SOA has a lot of baggage with it, right? Just like Ruby has baggage, SOA has baggage. It comes from the old worlds of Java and whatnot. So I don't want you to think about SOA when you're thinking about this. We're going to bring some new language in together. So if you want to scale and you want to deploy independently and you want to work on that, what you're talking about is software architecture, right? That is what this world is you're looking at. When you're trying to break up this really monolithic Rails app, you want to do software architecture. And I know what you're thinking. We're friends. I can read your mind. I did not go tell you to fuck yourself. You guys are the ones that want to do software architecture. You want to split up this application into its own little components, and that's what you guys want to do. I'm here to just chat you about it. But software architecture is really about partitioning systems. It's about identifying components and identifying how those components communicate together. That's what software architecture is. And so we have to deal with that. And so get the baggage out of software architecture, the world of that, and think about it in a different way. And for software architecture, the biggest component that you need to care about is abstraction. We want to figure out a way to encapsulate this functionality into a single component and how those components will talk to each other. So I don't like the word SOA. I like the term network-based application software. I think that characterizes what we're actually doing better. I don't know if we're building services. I actually am building network-based applications. These are these components that all work together and have to kind of coordinate to fulfill a request. I'm not necessarily building a service. I think I'm building an entire ecosystem and application. And this is a phrase from Roy Fielding from his dissertation, which you may or may not have read, and we'll get into more of that. So when you're thinking this, think about it from a network-based application software and think what that might mean. First, let's look at what your application probably looks like right now. Right? So you've got this monorail. You've got some cache, hopefully. You've got a caching layer and a database. And then inside of that monorail, you've got these objects that are pretty much behaving pretty well. You might have a God object or two that are communicating, but for the most part, you might even be using like service objects that are working through other objects. Most likely, though, your application looks something more like this. And that's okay. There's nothing wrong with that. We're talking a 4-year-old application. If you're looking at code from 4 years ago and you're not like, that's the worst code I've ever written, you're probably not doing it right. And so we have these things, and that's fine. There's nothing wrong with that. This is just how we grew up. But I'm your friend. I'm going to give you the benefit of the doubt. It's going to look more like that. So what if we flip this image around? What if we look at our applications kind of differently? What if we look at our applications as individual objects? If there's this small chunk of application implementation within these different objects, this is kind of how we function already. If you use anything from like Facebook or Twitter integration, if you use Zendesk or a payment processor, you have legacy applications that, from old Java service that was written by somebody that's long gone from the company, you're probably already building an application that looks like this. Calling out to these external services already look like network-based applications, right? So we're just going to take it to the logical conclusion. Instead of trying to wrap all of our application into this large monorail, why don't we split it out in the same way that we split out our graph system from Facebook and our payment processor to Braintree? Look at it that way rather than trying to think of like, well, I'm going to encapsulate everything into this one monorail and then have these services on the outside of it. Now, your application is probably a special snowflake. Everybody's application is a special snowflake. We saw what your application probably really looked like. And the thing about snowflakes is that they break anytime you change them. Every time. You move one little component, it breaks. Now, some of us have spent some time in physics. Understand crystalline structures. You move one little component in a crystalline structure, and the entire thing will fold on itself, right? And snowflakes aren't any different. And that's what your application is doing, because your application is a special little snowflake. It's falling in on itself every time you make another change. What we want is an application system that is modifiable, right? That is malleable to making changes. That's what we want to get to, because my applications are never done. No matter how many years I've been working on them, that application is never done. My application will always be changing. So how do we do that? So what ends up happening is you end up with these dependencies, right? Because if that crystalline structure has that one component moved, it's dependent on that one structure, right? The whole thing falls in on itself. Now, we have these applications that are communicating to each other. These objects are communicating to one another. And these objects are passing messages back and forth, as we saw in that diagram earlier. Now, each object has to know a little bit about each other in order to pass the right messages. Which message are you sending to which object? So that coupling creates a dependency. And we have a system for managing these dependencies. We call it object-oriented design. Sandy Metz has an amazing book on this topic. If you haven't read it, I think you should get up now and go read it. I won't be hurt. But we want to look at object-oriented design. We want to look at how objects can be applied to our application layers. Object-oriented design allows us to make flexible applications. So for those of you that aren't familiar with objects and object-oriented design, we're going to go over that a little bit, and then we'll get into some more detail. So an object is made up of two components. First, it's got state or data. It's got some information about it, and then it's got behavior. Now, this is all you need to know about objects right there, right? That graph is entirely representative of all things about objects. Then, when we have an object-oriented system, we have these other objects communicating. They're passing messages back and forth. Now, sometimes we have objects that behave badly. Sometimes other objects communicate to our primary object and manipulate its state directly. That's a bad object. We don't want objects that can manipulate state. We don't want objects that can manipulate data to other objects. We want objects that are fully encapsulated. The only way for state to be modified is through modifying through behavior, through this external application interface that objects have to call in order to modify the state of another object. This is a more accurate depiction of what we want in object-oriented design. And you're like, cool story, bro. We're not talking about objects. We're talking about applications, right? We're talking about how do we build these SOA applications, for lack of a better term? Well, this has already been thought about. And like most things in computer science, we're not the first people to think about it. This has actually already been done before. Long before us, someone came up with the idea of HTTP object model. This existed 20 years ago. You probably don't know it. It's changed its name. It's called REST. That's the same thing. So what we're talking about is REST. That's how our applications and our objects as applications can communicate to one another. REST is a series of constraints being put on top of HTTP. So, as long as you're still with me, we'll go over a little OO design now to understand that our applications can actually function like REST, or can actually function like applications. So we've got any number of things in OO that can help us do this. Things like dry and single responsibility. Not everything in object-oriented design is applicable to application-based, network-based application software. Mostly it comes around to doing with patterns. The Gang of Four book is great, but patterns are problem-oriented, and architectures aren't problem-oriented. So you can't just go and take the decorator pattern and plop it on a service and think that's going to solve anything. That's not going to solve anything. But there are some things we can use. So just be aware of that. So first, we've got single responsibility. This is probably the cornerstone of good OO design. Single responsibility is, do the smallest thing possible and nothing more. Now, you've heard this in other applications. You've heard this in things like, do one thing and do it well, right? Part of the Unix philosophy. Dieter Rams, a big inspiration for Apple design, talks about doing simple design is do the simplest thing possible, but not simpler. Sandy Metz talks about single responsibility on a system of cohesion. And I like this, because single responsibility doesn't mean you have to do this one very narrow thing. It just means that the things that it does have to be cohesive together. It has one sense of responsibility. And that's what's really important. And then there's don't repeat yourself. Now, don't repeat yourself often gets conflated with copying and pasting code. And it actually has very little to do with that. In The Pragmatic Programmer, Andrew Hunt and David Thomas talk about don't repeat yourself. And it's about where does knowledge exist? Where does the information about an application exist? And what we want is a single authoritative source. That's what the don't repeat yourself is. This object and this object cannot report on the same piece of information. Because if you ever change that information, then you have to change both objects. So that's what's most important. And then we want to depend on behavior and not state, or data, as it may say. So behavior is invoked by sending messages between objects. And if we've got a single responsibility object that has one sense, and we have that object that has dry, then that behavior exists in only one place. It's only on one single object. So when we depend on that behavior, then we only have to change it in one place, because it only exists in one object, and it's always only going to exist there. So that allows us to be much more flexible. And so that's what it means to depend on behavior and not data. Dependency inversion is a weird one, because I think the name isn't indicative of what it is at all. It's about depending upon higher level modules depending on lower level modules. In the end, you don't want anything to depend on anything. So this is really about building abstractions, about building an interface to your objects so that they don't depend on one another. And so dependency inversion is something that we can use, and it sort of comes inherent with single responsibility, and dry comes with that. Law of Demeter, or law of Demeter, depending on your pronunciation, is also another component. This one's a little trickier, though, because this is more of a guideline if I was a pirate. Law of Demeter is about one object talking to a second object to get to a third object. Now, that's kind of contentious, right? Because if I've got an account and I've got an address, can account not get to the city of that address? Is that some kind of violation? This is very much a judgment call, and you're going to have to kind of work through that. Just be aware of it, and that's something that's going to be on your radar. So, lastly, we have dependency injection. Dependency injection is about stateless functionality. We want to pass along whatever information another object needs in order to get the information to complete its request. We don't want to cheat our way around it. And the biggest thing that you'll probably see in application design is sort of an anti-pattern. So if you've ever built applications and you're like, I want to cheat, you probably have all these little services and they're all talking to a single database. You're like, I'm going to be good. These tables belong to that service and these tables belong to that service. I'm not going to cheat. Don't lie to yourself. I've done it. I've written applications that cheat because I don't want to deal with the network overhead of making a secondary request. The database is already connected. So why don't I just grab that information, eager load it into the final object and deal with it? So don't do that. And law of Demeter will kind of guide you on this. It's sort of indicative of it. But here's the public service announcement that has to go along with this. Cache is king. If you don't have a caching strategy when you start, you're done for. This application cannot go into production unless it has a cache, because network-based application software has so much additional overhead about the network spin-up times and the multiple requests you're going to have to keep making, that if you don't cache that stuff, your application will respond in 4, 8, 12, 15 seconds, timeout. We're losing sort of the adjacency that these objects normally would have and applying it across a network application. So you need to have cache. You know, networks have more application, or have much more overhead than just making a single service call. Serialization is really expensive, and you don't want to have to do it if you don't have to. One of RubyGem's biggest problems is, rubygems.org, is the serialization of the objects, and that's the most intensive component of the application itself to send them down when you do a bundle install. Serialization is expensive. So cache control and e-tags are your best friend. A lot of people use cache control and e-tags, but they don't use them well. This is something you have to get very familiar with and you have to understand in order to do this kind of thing. And caching needs to be a first-order feature. Again, public service announcement. Do not put this into production without some kind of caching already established. Putting 10,000 lines of code into production and then saying, like, I'm going to put a caching layer in later, you're never going to put it in. You're never having to, like, spend all that time re-implementing it. It's just a giant pain in the ass. I've done it. Don't do it. We're friends. Learn from me. So we spent a lot of time talking about how to group our classes together, right, our objects. But really, OO design is about message and message passings. And we have messages in network-based application software, right? We have these things already. They're called APIs. But this is not an API. How many people have done this? How many people have done response to JSON, and now I've got myself an API? It's okay. Friends here. We can admit these things. There's nothing wrong with that. That is something that we just did. But it's not an API for a number of reasons. It's not an interface. An interface is something that's thoughtful, something that you considered building. When you're designing an interface for a web browser, if you're doing CSS and HTML, you're building an interface, and you're thoughtful about it. You don't just dump shit on the screen. This is not thinking about what that interface is going to look like. It's also not really an application, right? This is a database access interface. That's all that is. And we were looking for application programming. So we want to think about the interface we're building. We want to build an interface that allows you to do application programming, not database access. So interfaces are all about nouns and verbs. In OO, our objects are often nouns and our messengers are often verbs. So, to use a basic example, user.create. I've got a user object, a user noun, I want to create something, right? It's very, very classic. But our APIs rarely have verbs in them, unless you were in 2002 writing PHP, and you ended up writing things that look like that. Or if you happen to be using any kind of JSP or ASP shopping cart system, if you ever looked at the checkout process and watched the URL structure, it looks a lot like that. I'm not talking about building this. I'm not saying, hey, let's get rid of this RESTful structure that we used to do and start going back to this. I'm not saying that at all. But this is not what we're talking about. This is not the verbs we're looking for. HTTP already does have some verbs, right? We've got the get, post, put, and delete. That's pretty cruddy, right? Create, read, update, delete. Thank you for the laughter on that. I'm good at bad puns. So if you've got a user, if you've got a get account 173, then that's kind of like a read, right? That's a verb and that's a noun. That's kind of close. But then your interface would be entirely limited to those 4 verbs and a couple other extraneous ones that don't really matter. But we don't build interfaces that way. We want an interface that's more verbose than that. So those verbs aren't going to do us. So you're probably thinking, I know because we're friends, what about Hypermedia? I've heard of this. This Hypermedia thing is coming out, right? This Hypermedia thing's pretty cool. And I am talking a little bit of Hypermedia. This is what we're talking about. Hypermedia is a series of constraints that Fielding put on top of REST, and it's really what he was thinking when he wrote the REST paper. His dissertation, The Architecture of Network-Based Application Software, is somewhat close to the title of his dissertation. No offense to Roy Fielding. So what we want to talk about is how can we apply the true nature of REST to these message systems, to our APIs, in order to create this much more object-oriented design. And this is not your Rails REST. Rails does a fine job at REST. It does a fine job at building RESTful resources like this. But it mostly stops there. If you look at REST inside of the Rails guides, it's actually inside of the routing system. And that's about building URIs. Now that's fine, but a URI is not an interface. A URI is actually an implementation detail. The nature that orders are embedded inside of accounts is an implementation. My application, if I was consuming that URI, I would have to know that, and it will always be that way. I would probably construct some client that knew how to construct this URI, and now I've got this really tightly coupled implementation to implementation detail, not to behavior. I want to tie to behavior. This is implementation. So what do we do? Hypermedia is a RESTful system that combines a media type and link relations. Perfectly clear, right? It's like clear as mud. Let's take a look at an example of this. So a media type is really for lack of a better phrase, a schema of how an application payload is released. So this is a HAL JSON, which is a schema or a media type for Hypermedia. And so you can see 2 major components. You've got the top component, which is the links array, and then below that we've got this embedded orders, right? So we're delivering 2 different things. We've got a series of links and link relations, and then a series of data. Now this is pretty important because this looks a little like state and behavior, right? If I got this back and I had an application interface that was able to go to the next order, right? Because I'm returning a series of orders. I want to go to the next order. I can look that up. I know exactly where that is. I'm not dependent upon what the structure of this account/order system ever looks like, if that ever changes, all I need to know is inside of the links array, I've got a next ability, and then I also deliver myself state. I've got my state, I've got a number of orders, right? So there's one order in this example, totaling 1 through 3, 7. And it's got its own behavior along with it, right? It's got its own link relation payload with it. And now imagine a world in which you had something that looked like that. What if I wanted to cancel an order? Now I know where to find that. That would be a pretty cool world, I think. So let's take a look at an example. I don't know if there's any GitHubbers in here. When I was at Railsbury and I gave this talk, there were like 11 GitHubbers in the room. And so I was really worried, like they're going to get really mad at me because I'm using them as an example. But they do a decent job at Hypermedia. At least they proclaim that their API is Hypermedia. So we're going to look at it a little bit and kind of see what future we might behold. So this is getting a single issue. You can see this is all from the documentation, basically copy and pasted and then put in a weird font. So getting an issue is pretty easy. You can see a number of components. The thing about Hypermedia with GitHub's API is that anything with an underscore URL key is a Hypermedia link. So their client consumers basically search through the keys and find these underscore URLs, and that's their sort of link relations that they can follow. So in this case, there's only one link relation. It's the HTML endpoint. And we see this issue is currently open. What if you wanted to close an issue? If you were building an object-oriented system and you were like, I have these issue objects and I want to close it, you would probably call what? .close on it? Makes sense. How do I close this issue? According to the API documentation, I have to send a patch request to a URL with a payload of state being closed. Well, that seems quite a lot like manipulating data and not implementing behavior, right? What happens if the state has multiple states? What if we're using Bugzilla and it's got like 7,500 different states to exist? Conveniently, GitHub currently has 2 states, open and closed. But now every client that implements this API has to remember and has to know what states can and can't exist. What happens if state moves somewhere else inside of the issue itself? And then our clients are now becoming very tied and very dependent upon these implementations. So anytime they change their API, my client has to change. And that's exactly what we don't want to do. So let's take a look at another example, getting a pull request. So similar situation here, but we've got many more URLs to pull from, patch, issue, diff, but none of them are closing or merging this pull request, right? What happens if I want to merge a pull request? That seems like something I want to do. As an object, as a pull request object, I feel like I should be able to merge it. That's behavior I think I want to implement. So how do I merge a pull request using the API? Well, this is the merge button API. And so you can see the URL structure is different here. So they've put a verb on the end of the URL, and then you put an optional payload of message YOLO, obviously. But is this truly Hypermedia, or is it an effect of the fact that they're not manipulating data, right? There's not a database backing this object. Merging a pull request isn't something you can say like, oh, I'm going to change this state from open to closed. Or did they really think through it as Hypermedia? Would it have been better to have a URL here that said the merge URL and then given that to me? And then I would know how to call that. So I'm not sure. I haven't had a chance to really dig into it with any of the API team at GitHub to find out what they were thinking on that. But I think I do like the notion here that, I've got a verb acting on some objects. I've got some nouns, I've got pulls, and I've got a verb acting on it. That's the world we want to get to. So some of the things that are kind of going on in this space. First, we're already seeing this happen, right? The world is already kind of implementing some Hypermedia. There's a movement, I guess, called Helios, which is Hypermedia application, Hypermedia as the engine of application state. Now think about that. Parse out that phrase for a second. Hypermedia as the engine for application state. It sounds like behavior to me, right? Helios sounds like it's behavior. And that's really important. Something really interesting here, though, is that how many of you work on mobile apps, have a client, native mobile app that is installed somewhere, or has a company that does that. Okay, that number will probably double next year, and the year after that, it'll be everybody. The problem with things like native mobile apps is that their clients are already installed. What happens if you change your API? You can't force an update to that application. That client will always be on that mobile phone and never be able to get rid of. New Relic has a series of, our agents have a long history, and there's a number of agents that weren't very smart at the very beginning. They didn't know how to talk to our collector network in a very smart way. And we can't force our users to upgrade. We're not going to say, like, sorry, that agent is no longer supported. You can't report data to us. We have to have all this infrastructure put in place in order to still allow these old agents to go and talk to our collector network through this proxy system. So if you've got a mobile app that has a changing API, because applications are never done, wouldn't you want something like the ability to do a merge? What if you built a client inside of your mobile app to be able to navigate this structure, like we see in HAL, whatever HAL is? So what if all you have to care about is that the cancel link always exists. And then your application, your client inside of that mobile app can just call the cancel. Whatever happens to be delivered, that is how you will cancel this order forever and ever. That sounds pretty nice. You don't have to keep dealing with these versioning systems on APIs and keep dealing with this mess of a junk drawer that probably is your API directory. We want to live in a world that's much more akin to that. So you can build custom media types. That's awesome, but that's also pretty awful. It's awful because it's hard to find client libraries for these things. How do you build a client library that everybody can use? How do I publish a gem that adheres both to the GitHub style of Hypermedia as well as the HAL style of Hypermedia? I can't, and that's a problem. I'm not saying that we have to unify. I don't think that's necessarily the case, but be aware that you'll probably be building your own client consumers, and in that case, make sure that's when Hypermedia becomes really powerful. When you can control the client for some existence, or how the client consumes an API, that's really what we care about. There's collections JSON, there's HAL JSON, there's the GitHub custom version. So that's part of the bad. And the ugly is that there aren't any HTTP verbs along with these requests. How do I know in this if there was a merge URL? How do I know if that's a patch request, a put request, a get? Most of that is missing out of most Hypermedia specifications currently. And so we need to start thinking about that a little bit more. I'm not suggesting we put new verbs into the HTTP spec. I'm suggesting that we need to follow along, and maybe this needs to be a tuple that has the verb along with it, that gets it's sent along with the payload, so we know how to complete this request. I think our APIs and our API consumers can be much more OO designed. I think it seems like that's an awesome world in order that I don't have to do these versioning systems on my APIs. I've done that. I've had to maintain them. They're terrible. I've made API proxies that translate an old API into a new API, and that's awful. I want to be able to just call cancel, and that order will be canceled no matter what the URL for that ever ended up being. So I want to say thank you very much for listening, and let's continue to chat. I'm on Twitter's at Amateur Human.